In this practice, let's try applying our mass action expression. Here we have a reaction of H2 and I2 making 2HI. We're told that the equilibrium constant is 0.145, and at the moment, we have these concentrations of H2, I2, and HI. Find Q for this moment and determine if the reaction is at equilibrium or will proceed left or right. Go ahead and pause and give that a try. All right, if you're back, well, I need to create my mass action expression for this reaction. That is always products over reactants. In our case, we only have one product. It's the HI, and it's going to be to the second power. Its coefficient is 2, it goes up above. Our H2 is to the first power, and our I2 is to the first power. This would be the mass action expression for this reaction. Our products over reactants, each to the power of their coefficient. Well, our HI is 2.1 to the second. Our H2 is 0.05, and our I2 is 4.4. This will equal some Q value, just whatever the quotient is for this moment. And so 2.1 squared divided by 0.05 divided by 4.4. What we'll find is that this is 20.05. This is way past the equilibrium value. Our Q is substantially greater than KEQ. This means we have too much in the top value and too little in the bottom value. So too high, too low. I need Q to be smaller, so I need less on top, more on bottom. That means I need less products and more reactants. And so this reaction will move towards reactants. It'll move left. If we try that one again with slightly different concentrations. H2, let's swap them around. Make it 2.1. We will keep I2 at 4.4. And we'll make HI 0.05. So let's just swap around some of our numbers and try to recalculate out this one. What is Q this time? And are we at equilibrium or are we moving left or right? Well, this time 0.5 squared is our HI. 2.1, 4.4. So I can plug in the values of the concentrations of each reagent and each product. 0.05 squared divided by 2.1 divided by 4.4. In this case, our Q is 0.000271. Much too small. We want it to be, as we saw earlier, 0.145. Now our Q is much smaller than KEQ. Well, if we think about why for the math, well, it's because of the values that we changed. We had 2.1 squared on top, which gives us a fairly large 4.41. But if I have 0.05 squared, this gives us a 0.0025. By swapping those around, we've changed massively what our top value is. Additionally, we changed the bottom value by some as well. Though that squaring definitely has a large effect as well. In this case, by having way less product and more of one of my starting materials, we found that our Q was too small. We got rid of too much on top. For any given concentration set that you are provided, you can find Q and figure out if your reaction is going to move towards product, towards reactants, or be at equilibrium. In this case, we will move to the right and we will form more product.